All right, our last part of this section talks about expectation. Now, another name for the mean of the probability distribution, that is your expected value. So we talked about yesterday how that when you find the mean of a probability distribution, it's what you can expect to get on average every time that you go through and conduct the experiment. Now, as we move through these particular examples that you're going to see, a lot of times we focus our examples on gains or what's the expected value of this particular raffle or something that's requiring you to go through and find or make different choices and decide if it's a good choice or not. So the formula is the same that we use in decision theory, okay? So what you're doing is you're still going through and you're finding the mean, okay? So you are summing up each x value times its probability. That's what we're going to do. Now, we are going to go through, we are going to set up the chart because I do think it's helpful. We're going to talk about your expected outcomes, and then we'll look at the probabilities of those outcomes, and we can go through and still use our calculator here. I'll show you by hand for the first one, but you are welcome to use your calculator as we go through and find the means for the rest of these. So our first example, Mr. Marzok is selling raffle tickets for 'Tis the Season for $5 each. Okay. Prizes are $500, $250, $150, and $50. You buy one ticket to help support the kids. So what is your expected gain? So I want to start first by setting up my chart. Okay, so you buy one raffle ticket to play. So your ticket is $5. Okay, so really, if you win the $500 prize, you paid $5 already to get that $500 prize. So when you think about what you're actually walking away with, you're walking away with $495 more dollars than what you had before you purchased the ticket. The same thing goes for every single prize. Okay, we have to subtract our $5 entry fee from each prize that we could possibly win. Okay, so if I win the $250 prize, I already spent $5 to play, so really you're walking away with $245 more dollars. That is your gain from partaking in the raffle. My next one, the 150, that would be 145. And then my last one, that last prize, the smallest one, I would walk away $45 richer than when I began. So these are all of our options. Now, the most common result that you're going to get from partaking in a raffle is simply that you just don't win anything. So you buy a ticket, try to win the raffle, you don't win. So really you're walking away with negative $5. You are $5 poorer than when you started. So these are all of my possible outcomes for partaking in the raffle. Now, I forgot to mention that this here should say 500 raffle tickets. My apologies. We're looking at selling 500 raffle tickets. Okay, so let's look at our probabilities for each one of these. Now, there was one prize that is $500. So one person out of the 500 will win. You will see the same thing. There's only one $250 prize. So one out of those 500 tickets will win that prize. And you're seeing the same thing for the other two prizes. There's only one that gets selected out of the total. Now, if you remember, our rules for probability distributions is that in total, they have to add up to 1. Now, in this case, that would be 500 out of 500. So I know that my denominator here has to be 500. I've used up 4 already. That means out of my 500 people that play, 496 people will lose. So let's set up what that would look like if you're doing this by hand. I'll choose a different color here. I'll use blue. All right, so you're still taking each x value, so I have the 495, and for expected value, we use e sub x. So our expected gain, our expected value, 495 times 1 over 500 plus 245 times 1 over 500. And we're going to continue to do this down the line. So 145, 1 over 500. And then our last one, we can just do minus 5, and then you have 495 out of 500. So going through, like I said, you can conduct this and do this by hand. You may also go through and use your graphing calculator to get your result. I'm going to pull that up just to show you. Okay, so I'll pull this down into my screen. Now I'm going to go through and I'm going to hit the stat button. I'm going to edit a list. I'm going to scroll up and clear the items that I have from class yesterday. Now all of my x values go into my list 1, so we have 495, 245, 145, 45, and negative 5. Now I'm actually going to go through here. I'm going to pull this up. It gets mad when you use the negative sign or the minus sign, so I'm going to say 45. There we go. All right, probabilities. 1 out of 500. And so I see that this 0.002, I might just put 002 for each one. Myself a little bit of time with the fraction. And then our last one was 496 out of 500. So I have those probabilities in there. I have my x values in there. If I were to go to calculate the mean now, I would hit the stat button, scroll over to calc. I'm selecting that one variable stats, that first option. Make sure you have L1 and L2. If you don't have that menu prompting you, remember it's L1, comma, L2. I'll scroll down and hit calculate. And that looks wrong. Oh my goodness, I typed in, I'm so silly. I apologize. That's not negative 45, Mrs. Dietz. That should just be negative 5. Oh, and I told you to not use minus sign. I specifically said that. Here we go. Okay, negative 5 and enter. All right, let's try this again. See, it's good to know if I'm paying $5 to partake in the raffle, I shouldn't be expected to lose $42 every time. That doesn't make sense. It should be about -3 something. There we go. Negative 3.1. Wow. All right, so what does that mean? Pull this over here. Okay, my expected value is negative $3.10. So this means we can expect to lose $3.10 over time by participating. You will pretty much not find any type of raffle or lottery where your expected value is positive over time. I mean, if you do find one that's positive, partake. All right, so let's take a look at some of these other examples here. And honestly, the hardest part is just setting up the chart and figuring out what your values are that get plugged in. Everything else, you can use your calculator plugin. It does that math for you. So we have 1,000 tickets are sold, $1 each, for a TV valued at $3.50. Okay, so either you win the TV or you don't win the TV. Now, you paid $1 to play. So let's say you are that one lucky customer that wins the TV. You were down $1, but you had a value win of $350, which means really your expected gain was $349 richer than before you purchased the ticket. Or you paid $1 and you didn't win anything. Now, how many people are winning the TV. One. You have one person winning that TV out of the 1,000 tickets that were sold. So that 1,000 is now your new denominator. We have 1,000 over here as well. All right, well, remember, you have your probabilities that have to add up to 1, which is 1,000 over 1,000. So what does that mean? 999 people will lose. Okay? Now, when you have a small chart like this, it might make sense to just kind of go through and plug it in by hand. You are welcome to use your calculator. And when I say that, I mean your lists and then typing that in. I actually might just go through and type this in like this. Might be a little bit faster, so I'm going to pull my calculator up. And I'm just going to type in what I see here. Okay, so I'll clear out of that. Scroll up. So I have 349 times 1 out of 1,000 minus 1 times 999 out of 1,000. Negative 0.65. So we're looking at losing 65 cents every time. So the value of the gain if a person purchases a ticket the expected loss by purchasing a ticket is 65 cents. Notice I said loss. Okay, I want to be clear with that one. We would be losing money because it is a negative number. Focus on question number 2. Little mishap here. All right, so you have 1,000 tickets are being sold $1 each. You have these 4 prizes. Okay. What is the expected value if a person purchases 2 tickets? Now, if you purchase 2 tickets instead of 1, you're looking at increasing your chances of winning. However, you are also spending $2 to play. So keep that in mind. Okay. We have 4 prizes. And then if we lose. So let's say we win the $100 prize, but we paid $2 to play. We're really walking out with $98 more than when we started. We win the $50 prize, remove that $2 we spent to play. We have $48 more than we did before. You're getting the idea. My other prize would be 23. 10 minus the $2 we paid to play would be 8, or we would be losing $2. Now, our probabilities, we're looking at 1,000 tickets. So that's what my denominator will be for all 5 sections. Okay, now we paid for 2 tickets, so that means we have 2 chances for each of these prizes to win. You recall, when we go through and add up all of our probabilities, we need it to be a total of 1, which is 1,000 over 1,000. I will add up these 4 prize chances, that's 8. If I take that away from 1,000, I would have 992 left over. Now, I recommend that if you have something like this that's a little bit longer, you might want to go through, plug this into L1, this would go into L2, and then you would do your 1 variable stats test on that. Okay? And then to go through and simplify, we'd be looking at our expected value being negative 163, so that we would expect to lose $1.63. Okay, last one, making it quick. Okay, you're paying $6 to play, so we're going to be subtracting $6 from all of our prizes. Our prizes are 10, so if we subtract 6 from that, we would get 4. An $8 prize would be 2, or we would lose 6. Probabilities here, we're looking at a deck of cards, so that's out of 52. To win the first prize, you need to pick a heart. Well, there are 13 cards out of 52 that are hearts. If you pick a face card, which is not a heart, you'll win 8. Now, there are 12 face cards in the deck. 3 of them are hearts, which means 9 out of the 52 would be left, and then our remaining probability